Hello everyone, I'm Swati and I'm going to present a topic on ripple carry adder. So, do you all know what is ripple in general? So, we know that when we throw a stone in water, it creates these ripples, that is, wave like structures. These keep on spreading on the tops of the water. So, similar thing is going to happen here. The carry of one full ladder is going to be the input of another. That is, it keeps on moving from one full adder to the next, similar to this ripple. Therefore, it is called as ripple carry adder. Ripple carry adder is a combinational circuit, that is, the output will depend only on the present input and not on the past. Here you can see that it is a combination of n full adders, and therefore it can add n number of binary numbers, and it is therefore also known as n bit parallel adder, since it can add n number of binary numbers parallelly, but the carry is not generated parallelly. Therefore it is generated only serially, that is, the output carry of one is the input carry of another. Then this is the program which we are going to use. This is written based on structural programming, structural module. Here we are writing ripple carry adder module, that is, we are going to define the outputs here, outputs and the inputs in the bracket. You can see that here we are using 8 full adders, and therefore 8 sums are being produced S0 till S7, that we have mentioned here using this. 7 is to 0 means from 0 till 7 we are having the output sum, and a C out is there, and the inputs carry is C in. And similarly you can see that the binary numbers A0, B0, A1, B1 till A7, B7 are being given, that is mentioned using this 7 is to 0, that is 8 inputs are being given as A and B. And similarly you can see that the C1, C2, these are the wires that we have mentioned here. And since we have used full adder, here we have mentioned the inputs and output of each full adder. You can see that for the first full adder, Cn is the input that is being mentioned, A0 and B0 are the inputs that also we have written here, and S0 is the output that we have given, and C1 is the output. So similarly for all the full adders we have mentioned here, and the full adder module is again written here. We already know that for the full adder the output is S and C out, and inputs are A, B and C in, and we know that the sum is going to be A XOR B XOR C in, that we have written here, and C out is going to be AB plus BC plus CA, that we have written here. And before going to this, let me show you the simulation. So here this is the program which I showed you, and now moving on to the test bench. Test bench means that we can vary the inputs and give here. So for this hashtag 100 means that after 100 nanoseconds this input will be given, and similarly again after 100 nanoseconds the next input will be given, and so on. And now moving on to the simulation part. So here you can see that when initially A is 0, B is 0 and C in is also 0, therefore the sum will be 0 and C out will also be 0. And as I told you, after 100 nanoseconds the input is going to vary. So here you can see that the input has varied. The C in is 1 and other two inputs are 0, therefore the sum is going to be 1 and C out is 0. Then again checking for another change, here you can see that B is 1 and the other inputs are 0, so therefore sum is going to be 1. And here you can see that if B is 1 and C in is 1, we have sum as 1 0. And similarly you can check for the others also. Here a is 1, then sum is 1. And this was the simulation. Now moving back to the presentation. Here these are the advantages of ripple carry adder. That is, we can add n bits parallelly, and also the design is very simple and results are accurate. And disadvantages are, the main disadvantage is that it causes carry propagation delay. That is, the carry output carry of one is the input of another, as I told you. So that time which it takes for moving from one to another causes a delay. Then therefore this increases the propagation time, and this makes the ripple carry adder very slow. Applications are that we can add n bit numbers, and it can be used in digital signal processing and also in microprocessors. And I would like to conclude with a quote related to ripple. Just as ripples spread out when a single pebble is dropped into water, the actions of individual can have far-reaching effect. Therefore, I hope that my seminar would have created good effect on you, and thank you.